Hey, welcome to another Stunt Rigging Toolbox talk. We're going to take the info we gained in the last one and just talk about design factors today. We've talked about it before, briefly, but in light of the information that we had from the last week of brake testing, I think it's really important for you to look at stuff and determine what you're really working at, especially since 6mm tech is the standard in our industry. We know after testing now, again, I will make the caveat, this is not the most ultra scientific. I don't have a gazillion-dollar computerized 1,000 time per second monitoring system, all that. This is a 12-ton brute force cylinder with a dyno that registers. I didn't look at the frequencies, but basically it's a max, it's peaked. So maybe in that peak sampling, when it's only sampling 200 times or 300 times, it's somewhere it may peak more. But the reality is for this, if I'm using the same equipment all along and testing the same way, it's a relevant factor. And right now, we're getting 2.4 tons to braking on spliced Marlowe 6mm Technora, and we're getting 2.7 tons, 2.75 tons on Samson 1/4 inch Technora spliced. And the difference between the Brummel and the straight berry is 100 kilos, 200. Again, I threw out the highs, the lows. Okay, so that's just an average. I mean, it's just going to be a working average, something that you could pick up a piece of rope and work off of. So when you go to set up a performer system, which will be some form of operation, whether it's a gold tail, it's a ratchet, it's a hand pull, it's a lock off in the clutch. Each one of those things produces X amount of force. You come out of your system usually on a jacketed rope. We use Runner Twin, which is a Dyneema SK99 core with a Technora jacket for our base stations. And then we come out of those and go to a connection of some type to the 6mm tech and through the pulleys to the performer, okay? So that's just a basic, simple system. I'm not going to turn this into a giant math explanation with the fleet angles of the pulleys and how much each anchor is seeing. I mean, I could get this into we could figure out on X number of performer force with X number of input or slow down what every piece in the system is seeing. But it's not really that much fun unless you're me to do for myself or if it's that critical. Needless to say, we usually oversize. Everybody thinks we oversize our equipment, but we're going to look at this diagram that I have over here. I'm going to flip the camera around and we're going to look at it and just go through it because the design factor is way lower than anybody in our business thinks they have. Everybody thinks, 10 to 1 because they base the rope on the manufacturer's, amounts, which may be 3.7 tons or 3.8 tons. And that's the factory number, or the spliced minimum braking strength, which will be 3.3, but that's on their machines with their splice. And I'm a good splicer, and I make the same splice every time. I've done all the variations of the splices here to test, and they're all I've averaged them out. It's we got the same brakes consistently every time based on diameters of termination, meaning a 40mm pin, a 12mm carabiner, thimble, without thimble, soft eye. We ended up with the same braking patterns all the way through. So we know that the bigger the diameter, the better the termination diameter. With a thimble, we're going to get the most the rope will hold, which is 2.4 to 2.7, depending on who's manufacturer. Okay? So that's simple. But let's take a second, and I'll turn the camera around, and we'll look at this diagram. Okay, kind of like school. So over here you have your performer. Let's just say he's 100 kilos. He's wearing a Sutra harness. We know the harness pick points are good, braking good to 1.8 tons, 4,000 pounds is what they say they're rated at. We know we usually use a Wishard shackle, which is 6mm. It's rated to 450 working, which is 2250 braking. And you always have to look at your MBS, your braking, minimum braking, and your working load limits, okay? And that'll tell you what design factor you're at. But 100 kilo person, Sutra harness, MBS is 1.8 tons, okay? The shackle working load is 450, the MBS is 2250, okay? So that's in kilos, and that's in kilos. So you come up here, you've got your 6 mil performer line. We know from testing that it's 2.4 ton for Marlowe or 2.7 ton for Samson, okay? We know our anchor, say this is a beam or a truss or whatever, our span set to these. Now, these should be far and above strong enough, but let's just calculate. So you're looking at your strap or your span set here, attaching your pulley to your beam. The ones we typically use are 1 ton straps, and they're rated at 7:1. I've taken these 1 ton straps on the brake tester and worked them well above 7 tons. The machine goes to 12. I've had them up to 8. 7.5 is no problem. 7:1, they don't break. So they're rated at 7:1 on the design factor. Okay? Your pulleys, if you're using a rock or similar, they're 22 kilo, call it 2.2 tons, 22 kilonewtons. So that's your MBS. It's not your working load. So you have to figure out what your design factor is going to be in relation to that braking. So if you're at a 4:1 design factor, that's 500 kilos, just so you'll know. So 500 kilos here, 1.8 ton, if you're going to go 4:1, is going to be less than 500 kilos, okay? So you have to look at these numbers. They're a lot lower than you think. Again, your pulley, same setup here. You have your 6 mil line, which we know is 2.4 ton, okay? We connect it to our base station. Most guys use a carabiner here, and they will wrap this line with a tiger tail tie, which is the bite of the rope wrapped and comes up the throat and down the throat and back into the carabiner, okay? Or they will use a circus tie, which is wrap, 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 and then half hitches around that, and then the tail in the carabiner, okay? So those carabiner wraps, any of those wraps, anything there is 1 ton to 1.2 tons on that connection, okay? And that's braking. That's an MBS. That's a braking, 1 to 1.2 tons. So what's your working load at design factor of 4? 250 kilos. What's your design factor at 2? 500 kilos. Okay? So all of a sudden, you go through, you've got this, which will hold 7 tons. You got this will hold 2.2 tons. Braking. So you've got to deal with a working load. This is a working load of 1 ton. Okay? Your harness is not even rated as high as your shackle. Okay? Your shackle is rated at 450 working load. Okay? But it's 2.2 tons MBS. Well, it's over your 1.8 ton MBS on your harness. Okay? So now your harness is your low number here for MBS. So look at your MBS. 1.8, that's 2.2. So you already know 1.8 is your low number. You come around through the system and you're at 1. So now you have 3.3, which we've tested, we call it 2.7 if it's Samson or 2.4 if it's Marlowe, that's tied with a 1 ton tie because we always have extra and we need to be able to add or subtract, so we never eye this out. If you use a bollard, I just tested my bollards to MBS, one of them that I make, and I got 1.8 tons, okay? 1.8 tons, so that matches your Sutra harness, but the bollard's destroyed at 1.8. It's MBS, it's bent. It bent the 12 mil plate aluminum that it's mounted to. So if I want to reduce that, call it 1.8 in half is going to be 0.9, and then half of that's 450. So you've got, at a 4:1, 450 kilos working load here. So then you come down to your devices. You've come through your shivs, and you're into your clutch. A clutch will have 1.4 tons before it slips. Okay? A ratchet, you have infinite amount of force. Depends on your system, of course, but mine are rated to 64 bar. At 7 bar, you're putting out 350 kilos of force. Okay? At 15 bar, that's going to be 700 kilos of force. Okay? So you've already exceeded everything minimum number. Your gold tail, if this is a 100 kilo human, 5 times body weight is going to be 500 kilo. You have now, if this is a 1 ton tie, you were at a 2-to-1 design factor. Okay? If this is a carabiner, dragon wrap, whatever you want to call it, wrap, circus wrap, all the various basically wraps, hitches to a carabiner or shackle, you're between 1 and 1.2 tons. You get 1.5 to 1.8 with a bollard, okay? So now, you know, you're design factor of 3 here, okay? So if you're getting this kind of 500 kilos of force here, look what you've got over here. You're at your working load on the shackle, but luckily the design factor is 5 here, but your design factor of that is only 2 here. So your whole system now is rated at 2. Your whole system is 2-to-1. This will fail before anything here fails. So you have to sit and think about this as a system and pick your lowest numbers and translate MBS to design to working load. So what design factor? This is 2-to-1 on a design factor because that's your weakest link. Then your design factor here is actually 4-to-1 because that's 2.2 tons. So that's a 4.5 to 1, but that's still 2-to-1. That at 500 kilos is within the working load on the shackle, and it's 1.5. Actually, excuse me, 500 times, it's 3-to-1 on your suture harness. It's 3-to-1 on your harness, but you're still 2-to-1 here. So your system, the reality is the weakest link in your system is right here. Okay, this is it. You're limited. And this is a braking, remember guys, braking of 1 to 1.2. If you have a bollard, if it works correctly, I just did mine, which are stronger than the Rubens, and I got to 1.8 tons. Okay? So you have to decide how you're going to design your system. And most people think, oh, well, I've got a 1-ton strap at 7-to-1. I'm good. Well, you're not, because here's your limit. 1 ton braking, 1.2 ton braking. So your whole system is only good for 1.2 tons. So when you start using these devices down here, or doing big drops on a gold tail, 500 kilos, 5 times body weight, a ratchet that can produce 700 kilos of force if you wanted to. It can produce more. Not that the performer can handle it, but all of this exceeds what your harness is capable of and of what your working load is over here. Now, 2 tons, over 2.2 tons here on a braking is 2.2 tons here, 2.2 tons here. So this is okay. And at 2.2 tons MBS, you're above your 1.8 on the harness. Okay? So again, you have to go with the lowest number. So in this system, up to this point, you're going to be 1.8 is your limit. Which, you know, 1.8 on a performer is pretty hardcore. But anyway, you're 1.8. That's your limit here. Despite whatever you size this to, 1.8 here is your limit. But then you come over here, and 1.8 is a braking. You come over here, and we find the braking on our termination, because we need to leave extra, is 1 ton. So all of a sudden, there's your low point, 1 ton. So now this whole system, with these super strong everything here, is limited by this, 1 ton. Okay? So then that becomes the rating on your systems, 1 ton. Like I said, if you put a spliced eye in here, you go up to 2.4 or 2.7. But now you can't add unless you have various lengths or a way, like extra rope and a clutch, to adjust this length, not doing this. So you splice this and use the length of line you have behind it to adjust it. Now, if it's a clutch doing it, 1.4 ton. But if you use the clutch and you back it up, the clutch can slide, but you've got the clutch tied. So there's your dead stop. So this implies putting a service loop in your system, okay? And if you want to keep it 1-to-1, you put the bite in and you reverse the bite back in. So you go 1 to 2 and then 2 to 1. and you reverse the bite, now the clutch will see the correct amount of force. So now you're back to 1.4 tons here before it slips, okay? And that's a maximum load. It doesn't destroy the rope, but your clutch will start to slip. We've proven that by pulling the clutches already. So 1.4 tons. So now you're up to 1.4 tons here. You're at 1.5 tons to 1.8 with your bollard here, but if you go to your spliced eye, you're at 2.4 up to this connection, but still you're going to slip at 1.4. Okay, but if it's backed up, dead stopped, then you're going to be able to get to your splice length rate, which will then be good here, but 2.4 or 2.7, that's your braking load on your pulleys. So now you would need pulleys that are higher than that. You would need 3-ton pulleys to be within your limits. Then you get over here and your harness is only good to 1.8 tons. So what you've done over there is make the system stronger all the way, put in new pulleys, but you're now limited to 1.8 on your harness picks, okay? And 2250, 2.2 MBS on your shackle. So you have to look at the system, and these kind of things are the big problem. There's ways around this, but you're still never going to get past this because of our performer. So the reality is, it doesn't matter what you do anywhere here, your braking is 1.8 ton of the harness, or 450 working load on your shackle. And that's at 4-to-1. So 450 becomes your kilo limit for this whole system. And this is how you calculate. That's why this rope was really important. It's why your terminations are important. But the bottom line is your performer termination and harness will determine everything else. And you have to translate everything into either braking and then decide your working load limits, or decide your load limits and then make everything be in the working load limits. One or the other. You can't mix apples and oranges. So just a quick look at how all that works, folks. Just a brief, today's a short one because this gets to be an issue when you think of a system. And most people don't think of this. But when you write an RA, a risk assessment for this kind of stuff, you have to know what your system is. You have to know what your loads are. I'm not too worried about the beams and anchors on this because we have truss mounted to multiple beams. This will hold more than 1 ton easily. This will hold more than 1 ton easily. Your pulleys become your next issue at 2.2 MBS because they're rock climbing gear. They're not rated as working load limit gear. Okay, so then you start looking at this MBS braking of 1 ton to 1.2 tons on your normal tie, and you see how the numbers go down in a big hurry. So the reality is you're at a 1 ton rating based on this, which is a 2-time safety factor for the harness. So now at 1 ton, this whole fancy system, or not fancy, is limited to 1 ton. This can pull a 1/2 ton, no problem, on a gold tail. A ratchet, you can pull 1/2 ton, no problem. And the clutch will hold 1.4 tons, so you can pull a 1/2 ton or more there. Okay? So now basically 1 ton. Well, if you're at 1 ton for this whole system and you're using this rope, you're going to be well within your rope limits. Okay, so your MBS at 2.4 is 1, 1.2, you're at 2-to-1 on your rope. You're 1.5 to 1 on your harness. You're good on your shackle, 2-to-1. You're at your braking on your termination. So what do you reduce that to? 2-to-1, so it's 500 kilo, 500 kilo. Great, so now you're at a limit of 500 kilo. And that's 1-to-1 for what the forces are here. That's not even a safety factor here, here, or here. So you have to decide, but these are how the numbers work out. And if you don't consider this, then you can't design a system properly. And this is just a really simple system, okay? Just a little food for thought today on design factor and how you arrive at it and the mix between braking, minimum braking strength, and working load limits. And you have to decide, based on NBS, what your design factor is and go from there. But that's how you calculate it. And again, I said you could calculate the forces on the beams. I could do the whole triangle and trig formulas on this for the fleet of these. And yeah, don't need to because it's Keeping it simple, you see how the numbers add up that quickly. Okay? And it's far less design factor than anyone would think based on the equipment we use. Okay? Have a good day and think about that.